Over the past few months, I've been building Handwave, a tool for smart glasses that translates the sign language alphabet. It's extremely simple. All you have to do is put on the glasses, look at anybody that's signing, and then click the Start Streaming button. It will work concurrently with any number of words chained together. For example, I can sign the word hello, and after a short delay, it'll be read aloud.
Hello.
Just like that. Handwave also works cross-platform, including on the web, with a TanStack Start front end. And I've included a variety of options here, including the ability to open a dev panel and share your screen, in case you wanted to test Handwave with some local video. But to get started, I can start my camera and then proceed to sign any amount of more elaborate vocabulary and phrases. For example, I can start by signing the word neural, or I could sign another word like hairstyle, for example. And then I could even try a name, like Lillian. I also ended up demoing at the Texas School for the Deaf and on NBC, though unfortunately I didn't get a chance to feature my own model, so props to these guys. I'm using MediaPipe to get the hand landmarks and then feeding that sequence through a CNN plus GRU temporal encoder trained with CTC, with around 3 million parameters. And the idea here was that it would run great on device cross-platform. This approach is inspired by some incredible research, which I simplified, dumbed down, and tried to replicate in a novel way. And the dataset that I mainly used here was Google's FSBoard dataset from an old Kaggle competition. The model isn't perfect though, obviously. You might have even noticed the predictions wavering between very similar output and unluckily sometimes really dissimilar output. And in general, the model is really bad with shorter phrases and sometimes delivers pretty messy output. So to combat this, I decode with CTC Beam Search and a KenLM language model. And I built this as sort of a crude autocorrect layer to really fix the deficiencies in my own model. All of the code is fully open source, including the model, and you can try it out at the link below or at handwave.sh. Though, of course, due to compute limitations, performance is far better locally. It's still super early and definitely still a prototype, but I think it's cool to highlight what a new computing paradigm like wearable technology might mean for older, more neglected problems.